Okay. So last time we spoke about using APIs, using SDKs, and we were able to try out some examples. Of course, previously we have used APIs, and there were a lot of questions around, um, you know, how flexible it is, how many APIs you learn. Then we saw that SDKs were much easier to use. They handle a lot of things for us. So just by way of a recap, um, we saw that there's a lot of companies right now that are providing AI models. So there's a lot to choose from. That just to show that the whole AI industry is growing and is blowing up so fast. So, and it will continue because there's a lot of potential in it. And some of us will see uh, some of the big stuff we'll be able to do, the things we'll be able to achieve with it. So having said that, um, we also saw that they also are a bunch of open source um, providers. In this case, they don't just provide you an API, they actually allow you to download the models, right? And use them. You have to install them locally on your computer. Of course, you have to have the computational capability to do that. Otherwise, it will be a bit challenging. And then, apart from that, you also have to, know how to configure it. You have to have a runtime that you use to run the uh, the, these models. For some of them, I think most of them they will run in the Olama. Olama provides a runtime where you can just download the open weights, what we call open weights, and then based on the open weights, um, you just run them in your runtime. And then there are a bunch of people that provide high performance inference. Then a bunch of people that provide unified gateway or a place where you can essentially just um, host your own model and have access to. Of course, the benefit of that is that for most people, if you can have a place where you can get models, then it means it's easy to access. So one of the benefits of this is that it has now made it very easy for ordinary people like us to actually gain access to some of these models. If not, it would have probably been very difficult for us to be able to achieve or do some of the things that we are doing now with models because they'll be really expensive. Okay, so then we talked about some of the capabilities of AI. So a lot of times, most people think that AI capability is just restricted only to text generation, but that is not really true. There's a lot more that you can do. Um, and the other thing is what most people don't also understand or realize is that a lot of these AI models, some of them are fine-tuned for one thing or the other, but most of them are fine-tuned for one thing or the other. So they might be good in one thing, but not necessarily good in others. So what that means effectively is that you have to figure out what you want, right? And then figure out which model will give you what you want or come closest to giving you what you want. Because if not, you'll be in a situation where maybe you pick the wrong model or something. And there are a lot of factors that come into play, right? But I think the most important factors are the cost factor, um, the latency. So smaller models are cheaper, of course, than larger models, not just cheaper in terms of cost, but as well as looking at the computational requirements or the computational need, you know, uh, to run that model. So if you are going for larger models, they will be much more expensive. They'll be very difficult, for you to manage if you were maybe running it locally in your environment. But at the same time, um, they are more powerful, they are more accurate. So there is actually the trade-off that you will have to do. That trade-off is kind of saying, okay, if I need power, if I really need power for this particular task, then I should probably go for larger models. But if I don't really need that much power for this particular task, then I should go for smaller models to save cost. So and you know, uh, that's basically what it is. Then the other factor is latency. So latency is how fast before you get a response. So again, larger models will have higher latency simply because they're larger, it'll take more time to do what they need to do and give you a response, right? But smaller models will do faster, but again, there's still the trade-off, right? Um, so that's another factor. Reliability. Reliability is also important. In this case, larger models will be more reliable. Smaller models may not be, but reliability is not just about the model size. It's also about things like the infrastructure that you build around it. Um, how capable is that infrastructure to handle the amount of traffic that will, you know, come into that server, right? So that's something that a lot of these providers pay a lot of attention to because basically it is um, that reliability is very key, especially if you are providing services for enterprise and so on. So for you as a user, the other thing you would be looking at is, okay, reliability for my own application. If I am building an application for a client, I want it to be reliable. But there are times when if you are making API calls and so on, things can be slow. Sometimes it goes offline. Sometimes you have rate limits and all kinds of things. So some of those are the factors that you look at and in picking what kind of AI models or providers that you use. We'll talk a bit more about all of this later. Then model specialization. And model specialization is essentially what what I mentioned here. Models are trained, they're not all trained on the same thing. That's that they specialize in different areas. There are those that specialize in text generation. There are those that specialize in reasoning, they are trained for that. There are those that specialize in coding, right? And code generation. There are those that are specialized in embedding, right? And in most cases, you cannot interchange all of these capabilities. So a model that, for example, is an embedding model, you can only continue to use it as an embedding model. You can't use it for text generation, for example. Okay. Vision models, models that are optimized for vision, for audio, for video, real-time voice. So there is voice, right? And then there's real-time voice, right? Real-time voice are models that as they are streaming the voice, you are sending them voice information and they are sending you a response in real time, right? Streaming kind of. So what that would mean is, for example, if you are doing language translation and maybe you built an app where you want um as somebody speaking one language, maybe you are channeling it through some kind of app that does interpretation. You know, you want another person to be hearing what the person is saying in another language. That has to be real time, right? So the demands for such applications would be much higher. Then, of course, agentic use. So most people feel that the large language model that you use for maybe agentic applications can be the same as what you use for text generation. Not necessarily, because even though agentic LLMs if all of these are basically text generation, including even the embeddings, apart from the vision, audio, and video that don't really deal with text, right? The um, the most of them do generate text, but what kind of text? That's very key. So agents are the kinds of models that are fine-tuned for agentic behavior. And agentic behavior means they should be able to understand, to reason, and to reason about the React loop, right? And what I mean, we'll talk about that later, which is, um, continuously um, working, responding until it gives you the final answer, being able to split big tasks into smaller tasks and things like that, and then knowing when to make two calls and all of that. So you find that those are all, you know, things that the different models, the models that are fine-tuned for agentic use will be better able to do. Tool use, I just mentioned it, right? And then multimodal. So those are the different ways that you can specialize, different models can specialize. Now, there are some models that may actually be able to do well in multiple of these areas. So it doesn't mean that maybe it only can do one. It could actually do multiple. So, but in all cases, if you go to any of these model provider, their websites, you will be able to see the capabilities of the models. Then the other thing is vendor independence. So you don't want to tie your application to a particular vendor. You don't want to tie your LLM or your provider to a particular vendor. So, but the thing is that major providers and model ecosystems continue to expand, across text, vision, video, reasoning, and agentic workflows. Okay, so the other thing we want to talk about is how do you consume? And we had done examples of it already. So the examples you can see you you can do via REST API and streaming. I showed examples of streaming already. So it's pretty easy to see how streaming is done. Um, you will call a streaming endpoint, you specify that it is streaming. You get a reference to a generator, and then you loop through that generator and you print as it is coming through. So, and these are some of the patterns you see. So you have REST API calls, which are standard completion, standard chat completion. That's what you get from most of the standard REST API calls. From streaming, you'll be able to get real-time token generation. So you'll be getting the tokens as they are coming in, right? Then you also be able to get batch requests. So batch requests basically means you are running the requests in batches. You're not running all of them at once because perhaps they are too much or too many, they are a lot. And you can split them into batches and process them in parallel to improve the speed. Then there are synchronous jobs, which are jobs that are long running. You are not going to wait for them to finish. When you are building an app around such, you won't wait for them to finish. You basically allow the app, the long running task to keep running and the user goes to do something else. So you typically will use queues and the queue system for that kind of thing. Then webhooks for event notifications. When things happen, I need notifications. So we also looked at the benefits of streaming, faster perceived response time, real-time UI updates, better chat experience, and progressive rendering. Progressive rendering is where you begin to see some part of the user interface, even when everything has not yet been retrieved from the backend, right? So this forms part of some of the techniques that you would use as a user interface builder if you're building a user interface. And this is an example of a streaming flow and some of the technologies that are used, including the server-sent events, SSE. Server-sent events are one-way traffic that, unlike a normal HTTP request where the front end will connect to the backend and retrieve, something. But in server sent event, the backend will send an event to the front end, but the front end has to register to be listening to it. Then WebSockets is basically two-way traffic between the front end and the back end. So you establish a WebSocket connection, and the front end can connect, send messages, send payloads, and the back end will receive and also send responses. Or the back end can even initiate sending payloads as well. So you have to decide which one, you would use. But in most cases, for this streaming thing, server sent events are used, right? Because it's backend initiating the traffic, right? But there are times when you use WebSocket, which is two-way, bidirectional. Then we have the HTTP chunked responses. So I talked about ND JSON, which is the new line delimited JSON. So it's a new protocol that has, been developed or devised just to make it easier for streaming in this context. And then asynchronous iterators. So the other thing that you also want to consider as someone that is building an application for the AI age, for you to use in the AI age, is how to always improve performance. You always want to ask yourself, how can I make this thing appear more intelligent? So batching and caching, performance improvements, right? So batching, we already talked about it. You can combine multiple requests together into a single batch call and send instead of sending them one at a time. So that reduces your network overhead. It gives you better throughput. This typically is where you have a lot of requests that come in at the same time, or a lot of things are happening at the same time. And it's a lower latency per request, and it's lower operational cost. Then you also have caching strategies where you can decide how you want to cache information. So again, because of the cost that's involved, right? You don't want to always make requests every time to the backend because now there's cost, right? The LLM is going to always cost you tokens. So if you have done something before, maybe a request, and you sent it to the backend, the LLM gives you a response, or the agentic backend gives you a response. And then the request is made again, but it is nothing much has changed, or nothing has changed, or nothing much has changed, nothing significant has changed. You could decide to return the cached version instead of making another API call to that expensive LLM backend. So some of the things you consider for caching, local cache, memory cache, which is, if you are on the backend, you can actually use a Redis. Okay. You have local cache with this cache. Redis doesn't exist at the front end. At the front end, you can use a CDN cache like Cloudflare, or just a memory cache, which is another type of maybe local storage or something. Then you have semantic cache. So then what are the kinds of things that you want to cache? Check the cache. If is it a cache means this is standard pattern of implementation. Check the cache. If it's a miss means I don't see what I'm looking for in the cache. Then you now query the model. So it's only when you don't see that you query the model. Then once you query the model, you store the result, then return a response. This is like a standard pattern. What they mean by cache aside is the cache is by the side. It's not straight through the cache. So and it's kind of a standard model that you use, or approach or pattern that you use when you are building. So always remember such things. Then what are the things that you will catch? Embeddings. Embeddings is a very good candidate for caching because we'll talk more about embeddings, but embeddings are the vector equivalent of any text or any input that you send to a large language model. So if the input is exactly the same, right, then you don't need to make another call. Okay. Then prompts that keep repeating, you want to cache those prompts. And interestingly, a lot of vendors provide ways for you to cache prompts at the back end. So if the prompt is the same, you don't need to resend that prompt again. You can cache the response that came from that prompt and keep it. So if the same prompt comes again, you simply return that response. Of course, whenever you're doing caching, there has to be an expiry because something may change. So for you to take care of that, you have to get that to expiry. Then two responses. That's another thing you can cache. So we'll talk about tools, but a tool is a thing that you have given to the LLM so that it can have capability to do stuff, right? So you don't always want to rerun two responses. That helps to speed things up. This one is not even more of a cost thing, but more of a performance improvement, latency improvement, and all of that. Then the intermediate results that the agent, is doing. Some kind of frameworks like LangChain and so on already do all of this. So just using LangChain, helps you to have all of these capabilities. So still talking about cost, latency, and concurrency, there is also at scale when if you're in a situation where you have to manage the AI infrastructure at scale. These are some of the things you can do to optimize your cost. You can compress prompts. You compress a prompt, you get fewer tokens. But when you're compressing prompts, be careful that you don't lose the context. There are many ways to compress, but most of the time it's always a summarization thing, right? You can use smaller models, like I said earlier. Smaller models will give you lower inference cost. You can impose response limits. So you control the size of the response. There are ways to do that. There is what we call max tokens, where you specify max token or max output tokens. You tell the LLM, don't give me response that's more than this size of tokens. But when you do that, you also need to be careful in your prompt to ensure that you tell the LLM the size of the token window. In fact, just yesterday I suffered for half of the day trying to troubleshoot why an agent I was writing was not giving me a response. And I found out that I gave it max output tokens that was too small. And it basically just stopped. Whenever it got to that point, it stopped and it gives me empty response. And I did a lot of troubleshooting. Interestingly enough, I've had this challenge before, but I didn't remember. So anyway, when it comes to output size and so on, you need to be careful. Caching, we already talked about that. So when you do caching, you just retrieve stored versions if it's the same as what was requested before. So you reduce API calls. That reduces latency, that reduces cost, and all of that. Then batch processing, you share overhead. There are overhead costs across the wire and even overhead costs in the LLM itself. So if you had multiple requests, you could batch it and send it. There are other ways you can optimize latency, where you could have different sources of delay, the network latency from the network itself. The model has an inference time latency. Like we said, larger models will take longer than smaller models. Slower computational capacity will take longer than faster computational capacity. So model inference time also adds to that. A large prompt will take longer to compute than a smaller prompt. Then if you have two calls to execute, of course, that will take longer because the model has to make the two calls, wait for the result, and then make use of the result from the two call to do what it needs to do. We'll talk more about two calls shortly, retrieval operations and so on. Then optimization techniques that you can use to reduce latency, like we've said already, streaming the responses, asynchronous execution, parallel two calls, which is a very nice thing. If the two calls don't depend on each other, for example, you don't need the response, the result from one two call to as an input into the next two call. Then most LLMs are optimized that way. They are kind of trained to make all the two calls at once, basically issue them all at once. And then when you receive them, you implement them and it gets all its responses and continues. Regional deployments. So regional deployments is having deployments to the user. It has to do with data center optimization. The benefit of regional deployment is that you are closer to the audience, to your customers. So all of the other things like the network latency is reduced and so on. Then context streaming. Yeah, so context will grow as the conversation grows with a model. So you need to figure out ways to trim the context because as the context is growing, of course, that means the context forms the prompt, the ultimate final prompt that goes to the model. So you have to minimize that. So other things, concurrency management, so come on, some of the patterns, you can use a queue worker that will queue stuff in the background. You can use asynchronous tasks that will run while other things are going on. You can use thread pools, which are pools of thread in multi-threaded implementation. So, but you don't need to keep creating new threads. You use threads from the thread pool. The thread pool allows you to multiple tasks or workers to share threads, event loops, and then rate limiters. Those are the common backend patterns. And typically you have all of this. So for Node.js, JavaScript, you can use promise.all or promise.all. Um, you know, what this does is it allows you to run multiple asynchronous tasks in parallel. Then you can use worker threads, bool, MQ, Fastify. These are all some of the technologies. In Python, you use the async IO, which is built into Python. Celery allows you to also generate workers and run. Redis has a queuing capability where you can queue jobs. Fast API, that's the backend. Fast API is built by design to be asynchronous. So it is also quite capable. All right, so let's talk about API orchestration. Um, what is API orchestration? So we have just looked at APIs, right? But when you look at APIs, um, what you're basically doing is you're making a call to a large language model. It gives you a response. Then, but that's not it. There are a lot of other things. When you are building a real app, a real enterprise app, or even just a real app, there are a lot of factors that come to play, which in most cases you don't remember them. It's okay for you to write and do an API call, but what if there's a failure? What if there is network delay? What if there is latency? Because in this age, when we're building AI applications, intelligence is not just about the reasoning ability of a large language model. It is also about the user experience. The user experience contributes to your app appearing intelligent. No matter how well your agentic backend or your LLM can reason, if a user has to wait for a few minutes after typing a question, it has to wait before it will not appear intelligent, right? It's just like you talking to somebody and the person is not answering you, even though the person is thinking very well of what to answer. But you assume that the person is dumb until the person begins to speak. So intelligence is not just a capability, it is also an um how do I put it? It's an appearance. It is it's an experience, right? So it's not just about what you have in you, but it's also what is expressed. Okay. So some of the things that you have to think about when you are um, building intelligent apps is model routing. Model routing is the principle of being able to switch between different models or model providers, right? And you switch it based on what is needed. So like we said, there's factors like cost and all of that, um, um, reliability, latency, and all of that, accuracy, a lot of different factors. So let's assume that you want to maybe you are building an app that you want to do a retrieval. You first of all do an embedding. You're going to use a different model for embedding, and then you're going to use a different model for um, the retrieval, right? Or for the text generation after retrieval, rather. Okay. And even in the process of retrieval, there are other things in more complex RAG scenarios. There are other parts of the retrieval and the generation that you bring large language models. For example, the ranking, right? There are people that retrieval approaches or strategies where you actually use a large language model to re-rank the results that come from the semantic search. We'll talk about that. So you need to, for such, are you going to go and get a really big, expensive, slow model, or you're going to look for a very tiny one that can do that? It doesn't need to be too accurate, but it's good enough. It's much better than using hard-coded rules, for example. So model routing is, we'll talk about that shortly, but it's really about being able to switch between models that you're using. Retry handling is another thing. So retry handling is if your API call fails or your SDK call fails, right? How do you recover, right? Do you just throw an error message to your user and say, no, okay, backend has failed? What if it's a temporary glitch? What is a temporary problem? What if it's just a rate limit? Okay. So retry handling means you are able to code it into your app to try again, but it's not going to try again forever. So that's why it's a bit tricky, because if you keep trying forever, it also becomes bad, right? So it needs to know um, when to stop trying, but it needs to know that it should retry and keep trying. And even in retrying, it needs to be smart. So if it's getting a response that says, for example, network failure, you can retry. But if it's getting a response that says rate limiting, then you have to back off. So those are some of the things. Then failover management. Failover management is if you are using one model or one system and it fails, right? Does your application also fail completely? Do you lose the intelligence capabilities of your application just because something failed? Or do you have a backup? That's what failover basically means, where it switches over to something else and continues to operate. Tool execution. So we'll talk more about tool calls. Observability is very, very key. Um, what's going on in AI is so complex. You need to be able to see what's going on. You can't make guesses. It's not like traditional programming where you would make guesses and say, "Oh, I know this," because the LLM is a black box, effectively. Neural networks are black boxes, and you cannot really say you can explain what's going on inside there. So the next best thing is observability, um, but not just um, the models, but what's going on, your entire workflow. Rate limiting. If you're building apps for your users, you are using your API key, you're paying for it, okay? Or you're using a user's API key that they have put into your application, they are paying for it. So you still need rate limiting so that you don't overwhelm the system, especially considering that these large language models have high latency. If you have a lot of requests coming in, sometimes you end up having a lot of queuing and so on. Then authentication, of course, that one is standard. I don't even need to explain that. Cost tracking. So that's really orchestration. Orchestration means all of the things you need to do in order to ensure that these API calls are seamless. From our own standpoint, when you're using VS Code, for example, and you're using Copilot on VS Code, and you're doing a lot of stuff, it's thinking, it's spinning, and then it comes back and tells you, oh, this failed, it will retry. That's all orchestration. It involves all of this. Sometimes your network goes down and it tries to make an API call to the LLM. It doesn't get through. It comes back and tells you, retry. Do you want to retry? Or sometimes it retries for a while before, failing and telling you, okay, it's gone. Try again. All of that is part of the what we call orchestration. So routing, when we talk about model routing and other things, there are different um, approaches, there are different strategies. Okay, so you can have cost base, like we've talked about. You want to optimize your cost. There's also latency based. You want to optimize for speed. There's capability based. You want models that will give you the best response, the most accurate response. Then you have fallback routing for reliability, which is if I want to be able to fall back if my primary provider fails. I want to have a secondary and even a tertiary that I will fall back to. Then ensemble routing is a situation where you want to get opinions or responses from different models and compare them. That's ensemble. Multi-provider routing is another kind of routing where you're not just switching between models in one provider, but you also go to multiple providers. So you can actually switch between multiple providers. And you have an orchestrator that's going to do that, right? So these are popular backend stacks that you can use for building your backend. Fast API, you still see Fast API is up there. Light LLM, Celery. In Node.js, you have Express, you have Nest.js, and FullMQ. So that's kind of a summary of what the things that you know around API calls, around SDK calls, around accessing models. So you can see it's not just a straightforward, oh, let me write an API call, fetch or request. It's not just that, there's a whole bunch of things. You can do fetch and request just for learning purposes, but when you're building apps that you want to sell to people or people are paying you to build, you definitely want to make them very robust, very solid, and very reliable. Okay, so we will now talk about LangChain. So remember I told you that last time we looked at some of the SDKs that are available for us to use, and you will see that we could do more interesting stuff with all of these SDKs. However, LangChain is kind of like the one that trumps them all. LangChain is essentially a framework that its sole purpose is to allow you to build large language model powered applications, right? That's all it does. And um, it has gone through several revisions. I think as of last year, a new revision 1.0 was, before it used to be 0. This, 0. That, but last year version 1.0 was released with a whole totally different API, total interface revamp and overhaul. And a lot of things were pulled out from the core into their own packages and modules. The core was kept, very clean, having single responsibility. There are other things because LangChain does a lot of things. Initially, all of those were just jumbled up into, the core, but those have been removed. And we're going to talk about some of the things that LangChain does. Over time, as we go through this, whenever we touch a new topic, when we learn how to do it on our own without LangChain, then we'll learn how to do it with LangChain, just so that we can understand the difference. So today we are going to learn how to call models using LangChain rather than just straightforward SDK calls. We'll do model routing and so on. So some of the core capabilities that come with LangChain: prompt management. So they have ways you can load prompt templates, right, from files, using standard, and then replace dynamic variables in the templates with real values at the point of calling the LLM or the agents. Then model abstraction, which we are going to look at. Essentially, what model abstraction means is you have a single API that you can use to call any model from any provider, whether it's an OpenAI, whether it's Gemini, whether it's Grok, whether it's OpenRouter, whatever it is, right? Anthropic, Hugging Face, and so on. So it now makes it easy for you to do model routing, which we're going to look at. Tool calling as well. It allows you to bind tool calls to models. So those models will have the capability to make tool calls. The only thing is that when that happens, you yourself will have to handle the tool calling and send the result of the tool call back to the LLM for it to continue reasoning about. Then, of course, LangChain is now all about agents. In fact, right now, the AI world is all about agents. It's an agentic world right now. And if you're not there yet, yeah, you have been left behind. So LangChain has kind of been repurposed around agentic, AI. Initially, LangChain was based on prompt chaining. That's why it's called LangChain, because Lang is a Germanic word that means long. So basically, LangChain means long chain. And it was called that because it was really based on prompt chains, chaining the prompts. But that whole idea of chaining prompts has been left behind since 2024. So right now we are talking about agents, because the thing with prompt chain, which we are going to look at next week when we talk about prompt chains, or the week after, is that you, the developer, you still have to decide the sequence of the chain, the steps, of the chain, what goes into the chain and so on, right? You have to make all of those decisions yourself. So it's kind of um, coding time. It's not dynamic, but agents are more dynamic. Agents can figure things out on their own, not you having to tell them how to do it, how to do it. You tell them what to do, but you don't need to tell them how to do it. They can figure that out. Then the other thing that LangChain provides is memory. Memory, remember we've seen that large language models are stateless. They don't have any idea or any memory or any remembrance of what you just sent to them. If you just send a prompt now and then you send the next prompt, they will not know. And I'm going to give that example shortly when we get into the bit of hands-on. So how do we introduce memory? Because no matter how well an agent can reason or an LLM can reason, without memory, it is still going to be dumb, because memory is another key element of intelligence. You have to remember previous conversations so that new conversations will fit into that same context. So memory is actually implemented not at the LLM, but by um, what I usually call the scaffolding that you build around the LLM. And LangChain helps you to do that. So instead of a typical example of memory would just be an array or a list that you keep pushing in each conversation. When you send a request, what you sent, the prompt you send, you push it in. When the AI assistant responds, the response, you push it in. And then your next request you push it in. So you now end up having a long list of what you said, what AI said, what you responded, what AI responded, and so on. And each request you make, you have to still send that list in its current state. That is how you maintain the memory and the context of the conversation, right? And if you're doing it manually, we will do it manually when we get to memory. And you see that having a framework that automates that process for you, it really helps a lot. So that's another thing that LangChain provides. Then retrieval augmented generation, RAG. Now, retrieval augmented generation is an entire technology. It's an approach to augmenting the capability of a large language model. We'll talk more about it, but because it has multiple elements to it, it's difficult for you to build. If you're building from scratch, you can actually do a basic RAG from scratch, but that's all. So LangChain helps to make it easier so you can actually look at the more complex aspects of RAGs. And then workflow orchestration. So workflow orchestration is when you have multiple things to do, a lot of steps in a workflow. The LLM, they needs to keep track of it and keep track of what has started, what is in progress, and what has been completed, right? LangChain helps with all of that. So the architecture of LangChain, we have an application. You plug LangChain in between your application. The application is your own app that you build, and then you plug LangChain in between as a agentic framework layer. And then you connect LangChain to your tooling. the models that LangChain will call, the tools that you would build, the memory, right? And retrieval, which requires databases, semantic vector databases, and so on. So that's typically what it is. Ideally, without LangChain, you would have had to do a lot of stuff yourself. You would have your application connecting to these same things directly, but you have to write a lot of code inside your application. LangChain takes away a lot of that. So for models, we have the LLM abstraction. For prompts, we have prompt templates. For chains, we have the sequential workflows that provides chains provide capability for sequential workflows. Then agents, dynamic reasoning, like I said, tools for external integrations, and then memory for conversation states. So we talked about routing, and you see that LangChain, like I said earlier, provides a unified access for you to connect to different model providers. It gives you that. And these are some of the examples. There are far more than this, right? There's OpenAI, there's Anthropic, there's Gemini, there's Hugging Face, Olama, Grok, and so on. So many others. Then it also provides middleware and hooks, right? So middleware allows you to intercept the traffic that LangChain is sending out to this. In fact, whatever is going on internally in LangChain, not just the traffic is sending out, but what is receiving for you to configure. And then when you're even selecting which model, maybe as part of model routing and so on. So it has middleware for intercepting requests. It has callbacks for logging and tracing. It has hooks for you to modify execution. And then it allows you to do retries. Remember, I just talked about retries for fault tolerance. And then it has guards and guardrails to ensure that you can constrain the behavior of your um, large language model around what you want. It doesn't go outside of those boundaries. Then, of course, model routing, we've already talked about it. So you could decide, simple query. If you have a simple query, for example, you can have rules that say if a query is simple, you choose a smaller model that is fast for small queries because of small context window and all of that. But once the query becomes really complex, then you need to get a reasoning model that is larger and send the query to that one so you get a better response. Okay. If the query has to do with code, there are models that have been optimized for coding, like I showed you earlier on. Different models are optimized for different things. So that's what allows you to do this optimization. And model routing is right there to help with that. So if a question was around code, you could then um, channel it to a coding model, right? If the question or if it was an image that's uploaded, you could channel that to a multimodal model. So these are all the kinds of things. Of course, the question you could also ask is, how would I know which is which? And that's where you could even use a small model to decide what classification the prompt or query is and where to send it. So that's the interesting thing. So LangChain provides a unified abstraction layer for you to interact with different AI model providers. The interface is the same, right? So it allows you to easily switch between providers. You don't have to rewrite your whole code. So if you remember when we were writing code around using the SDKs, if I was using the OpenAI SDK, for example, I'll use chat completions create. But if I'm using Anthropic, I'll use clients.messages or create. If I was using Google Gen AI, I'll use client.model dot generate text or something. So for each one, it's different code. So I would have had to write my own abstractions, right? Or just write it based on one provider. Then what if I need to switch the provider? Then what will happen is I will have to go and rewrite the entire code. Either that or write my own abstraction. So, but LangChain provides that abstraction, and we're going to see that in a short while. So it allows you to switch between providers easily. It allows you to even compare models. So you could run the same prompts through multiple models and see what response you get and which one is better. You even see it while you are doing some stuff. It allows you to build a multi-model system, right? Note, this is a multi-model system, not a multimodal system. Multimodal system has to do with modalities, right? What is the nature of the content that the model is, trying to understand and interpret. But this is a multi-model system where you have different models that you want to either run in parallel or you want to be able to switch or you want to use for evaluation and so on. Then it also allows you to implement fallbacks and routing, like we said, and it helps you reduce vendor lock-in because your code is not tied to a vendor-specific interface or API. So that's the benefit of LangChain. And again, these are the common providers that are supported. Much more than this. OpenAI, Anthropic, Google Gemini, Hugging Face, Mistral, XAI, Azure, OpenAI, and a bunch of others. So if you look at this, right, before, as at last Wednesday, this is what we were doing. Well, for us to call, you know, an API, we did client chat completions create. This is what we did with an OpenAI SDK. And then if we're using Anthropic SDK, you see that it's different. You import Anthropic, you call Anthropic, response is client.messages.create, so it's different. Even the structure of the payload that you send will be different. The structure of the response, the shape of the response will be different. So this makes it difficult. But with LangChain, you're just going to create a single chat open AI, which I will show you shortly, right? And for you to call it, you just use a single interface to call, invoke, that's all, right? So regardless of the provider, you will be able to use the same thing. So what is happening at the provider creation stage is the only place where there will be a little bit of branching in your code. But the rest of the code is the same. So benefits is easier migration, cleaner architecture, faster experimentation, and multi-provider support. Right. So this is how you can do it. So like I said, the way LangChain is structured now, things have been pulled out. So for example, um, each provider has a separate package that integrates that provider's SDK uh, with LangChain, essentially. So if you want to use all of this, you have to install all of these packages, right? But you have to install the core LangChain first, right? And then this is not just all, but right now we're talking about models and connecting to models, right? But later on, when we talk about things like RAG, you see that text splitting, document ingestion, um, semantic vector databases, a whole lot of stuff. You see that LangChain is huge. There's a lot in it. Okay, so we are going to go look at a bit of a deep dive into LangChain while also doing some few examples. I may not have enough time to do examples in both. Well, I will try to do so. Okay, so first of all, let me pull in the Jupyter notebook that contains. Let me see if I can easily access it. Um, so this may not come quickly, so I'm not going to. Um, okay. So I have a notebook already that will take this to look through and to see what you can do with LangChain. And then we will also do that. I'll go do some of this in VS Code using Python and also using JavaScript. So yeah, I already talked about a provider, a model provider, right? So in LangChain, there are concepts called models and providers. I would encourage you to go check their documentation at docs.langchain.com. Um, just go to docs.langchain.com and then you can start anywhere. But typically, maybe you want to start with models. So so they have deep agents and then all of that, but you may want to just start with the LangChain documentation here. And you can see agents. Well, this is how it's not hard to install it. It's just a pip install or UV install. Their documentation is both for Python and for Java TypeScript. So if you switch to TypeScript, you also get all the code examples will be in TypeScript. The concepts are the same, right? It's just the code examples that differ. So here, this is LangChain core. You install npm or pnpm install, right? pnpm add or yarn or bun LangChain at LangChain core, right? And then you can add other integrations. So OpenAI and Anthropic, this is what will give you the model integration. So basically that's for every of these dependency you want to install, that's how you would install it. Now, so let me still go back to um, Python. Um, you can go check out this quick start as well, and you have to set up API keys. I think I've shown how to do that. A lot of these providers already have kind of hard-coded API key names that they look for. So even if you don't provide it in the constructor, when you are creating either a model or whatever, if you have a specific name, they will look for it in your environment. So this is a good one, a good example. They will look for this if it is OpenAI. If it is Gemini, it will look for this. So even if you don't specify it, but if you have this in your environment somewhere, either you export it or you put in a .env file and you use a load.env or config um, um, .env.config, right? If it's JavaScript. So they will look for these very specific names. So there's been a lot of kind of unification and standardization of the approach. Now, models is where we start, even though agents are at the top, because of course, agents are agents. Um, it's very easy. You need to understand the concept of um, a provider, right? So let's look at some of it. So provider are the people that provide models. And we've seen there are a lot of them. I showed you the slide. You can still go back and check this slide where you have so many of them. I don't know if all of these providers are integrated into LangChain yet, but most of them use OpenAI SDK. So you can actually still find a way to connect to them if you use OpenAI. So um, so you go to models, right? Um, I think we've already seen all of this, so I'm not going to go through a lot of the theory, but I'm just going to take us to look at this. So this is OpenAI. Now, if you're using Jupyter Notebook like I am, you find that a lot of these libraries are already installed, pip installed, so you don't need to install them again. But if I try something that doesn't work, I can just pip install it. So here, the OpenAI, um, this would be like normal vendor specific if I wanted to, right? It might not even be installed. I might need to install it here. Let's see. So this, I would have to use two different approaches for this. Okay. This will give me an error. Okay, so first of all, it tells me that I have to pass in the API key. Okay, so that's like what I said. The client, I need to pass that in and then call this. We did this already, so I'm not going to spend a lot of time on this. Anthropic, the same thing. Now, Anthropic is probably going to fail, no module, because it is not there. So I have to install it. So in this case, if I want to bring this is normal Anthropic, their own SDK. So I would pip install Anthropic. This is not the LangChain Anthropic integration. This is just the Anthropic SDK alone. The OpenAI SDK is already installed, it's pre-installed. That's why it did not give me that. So this is now kind of installing it. By the time it is done, I can run it. Okay. So I no more have an error around the module doesn't exist, but it is now telling me I should have put an API key. That's the one argument, right? Um, okay, create rather. So um, this is essentially how I would query if you hover over it, you see all of this. You can specify the messages and the model. And I think we've done this before. But yeah, if I wanted to make a prompt, I would say messages equals, and then I'll have a list. And then I can say, how is the weather today? Right. Well, this will not run still because I need to specify max tokens. I need to specify model. So I could specify a model equals maybe Claude Opus 4.0, and then max tokens. So this max tokens is what I mentioned before. I could say 10,000, right? Well, this will still fail because I didn't put an API key, right? So that would be the next problem. Okay. So anyway, I would have to use two different ways to do this. And then, but with LangChain, I just have a model.invoke. But before I have a model.invoke, right, this is kind of like how I would do it. But I first of all need to bring all the providers in. So I think LangChain is already installed, so I don't really need to install it here. It's already installed. As a matter of fact, if I reinstall it, it may even um, clap back at me and tell me that I'm installing a new version, but it's already installed. That's why it says requirement already satisfied. Okay, so you can even look at what has been installed. LangChain has been installed, LangChain Core, LangGraph has been installed, Pydantic, LangSmith has been installed. Then all of dependencies and all of LangGraph and a whole bunch of other things. Okay, now for me to interact with providers, I have to install the provider packages. Okay, so provider packages that I will install um, are these, right? I will install LangChain OpenAI for the LangChain OpenAI integration, Anthropic for the LangChain Anthropic integration, LangChain Google Gen AI for the Google Gemini, Mistral, and all of them. We even have, I think we also have a LangChain Open Router. Then we also have a LangChain Grok, right? And a bunch of others as well. Then environment variables. So I'm going to move these environment variables. I'm not going to export. Typically what I do here, of course, is I will create a .m file here. And then in this .m file, I will create a new file. Yeah, .env. So that's what I do typically. And then you can put in the environment variables. This is .env, so you're not going to use export. Export would be if I'm doing it in a command shell like bash. I'll just use it as it is. And then the values will come in here. So when I'm ready to use them. So it could also have open router. API key. You can also have Grok API key. Then you can also have Hugging Face API key. So a bunch of them. Okay. So now I can then get what we call Chat OpenAI from LangChain OpenAI. Now, the reason why the model is not found, of course, is because I haven't installed the LangChain OpenAI integration, right? So I just wanted to demonstrate that you actually need to install that integration. So I'm going to run this to install all of them so that any one of them that I want to use, I will use. And while this is going on, I'm going to go fetch some API keys. I'll look for the API key for Gemini, which I have been using Google Gen AI, and then I'll look for the API key for OpenRouter and Grok and the Hugging Face. So let's see if I can get those. Um, or maybe I'll just take one. We'll try maybe a few examples. Mm, Give me a second. Let me bring that in. So yeah, so I have one that I have picked up for Gemini. Um, I have another one that I picked up for OpenAI, and I think I'll just use those two for OpenRouter rather. So okay. So, but basically the same principle. Once you're installed, you have all of them, and then so the next thing would be this is now available, okay, and you can make API calls. Of course, I don't have API key for this one, so I will use this same one, and I show you how flexible it is. With Anthropic, the same thing. If you look at this, you see that it's the same interface, right? You have you specify the chat integration class. So this integration class is a wrapper class that LangChain provides around the OpenAI SDK. And then it's an adapter pattern, basically. So it follows the same pattern. You specify the model name and you specify the temperature and other parameters here, right? It's as simple as that. Um, and then once you have created the model, which is now pointing to the LLM at the other end, you can then create call invoke, and it's going to run that. So then, yeah, so we'll talk about some of the key features of the chat OpenAI GPT-4X support. Streaming is very key. Tool calling also is very key. It has a JSON mode, what we call structured output. Then you can have vision models and audio models. Now, then you also have Anthropic Claude models. So in the same way, you can see it's the same thing, except that we are now using Chat Anthropic instead of Chat OpenAI. So again, this is a thin wrapper around um, the Anthropic SDK that we saw earlier. Is this same SDK, but is this same it's SDK, but we are now having just thin wrappers around them. And those thin wrappers, the main reason is for them to have the same appearance, the same interface, basically. So you still specify model temperature and other things, and you still get a response by calling invoke. So you can now see how everything is now getting unified into a single interface. So these are strengths of Claude, right? Claude can handle long context windows, strong reasoning, is good with summarization. Claude is also really good with coding, task and all of that. Then Gemini. So for Gemini, you again from LangChain Google Gen AI, you import chat Google Generative AI or Google Gen AI. And then we can specify, let me use 2.5 Flash. I think I have access to 2.5 Flash, right? And well, this time I should get a response because I have put the API key there. Um, if I don't get, then maybe it should be Google Gen AI. Okay, so this is Google. Oh, okay. I missed a step. So again, remember, I just created a .m file. I need to load the .m file. So I am going to do that here. So instead of exporting environment variables here, this is okay. I am just going to import um, from .env, import load.env. So load.env allows you to load any .env file. You import it, run it. JavaScript has equivalent. For JavaScript, you would import config from .env, still .env, but you import config. So in Python, it's called load.env, but in JavaScript, it's called config. Then you run the config function. And when you get true as a response, that means it was able to see a .env file and it has pulled it. Okay, so now that I've done that, I can do this again. So this time around, the API key is there, right? And you can see it's the same interface. So that's the beauty of LangChain. I don't need to learn so much about how all these other API, uh, SDKs, all these other AI vendor SDKs look like, right? And we'll get our response or content. You can also see the way you get the response back is very simple dot content, not all of that dot chat dot, whatever. There were different ways that you would access them, right? But this one, you can see it's very simple. So Gemini has multimodal. Gemini is really good with multimodal, by the way. If you are using multimodal, like you have images you want it to do stuff with, you can go with Gemini, right? Large context windows, fast inference, and of course it has Google ecosystem integration. Then Hugging Face. So I didn't install Hugging Face, but yeah, I think I can install it separately. Since I've already run all of these ones, let me just run it above that Hugging Face. So you see Hugging Face, it's not hard either. Same thing, pip install LangChain dash Hugging Face. You also see that the installers have the same pattern, right? You also, once you install this, of course, all the dependencies also get installed, sentence transformers and all of that. But this is a Hugging Face inference package, right? It has an inference package. So it's going to install. You see a bunch of other things already installed. So it's just installing this one. And with that, this is now available. And I think I have a Hugging Face key as well, which I added there. Okay, I'll add HF token. I think I have HF. Okay, I did not put it. HF token. Um, yeah, I don't have it here, but it would basically be the same thing. Okay. Then the other one that is not here, but I can add easily is we could also do open router as well. So you can also do LangChain open router, right? So you import chat open router. That's what you will use. So you see, Hugging Face is a bit different slightly, because of how their own is. But at the end of the day, it's kind of still similar. So you have model, and we could use this. I don't know if Mistral is available to me, but yeah, we can do NVIDIA Nemotron. Um, yeah, let me go look for the full um Nemotron Super Free, which is a really big model. Um, I have copied it. I think I showed us how to copy it last time. And you can also specify temperature just like we did with the others. 0 0.3. And that's it, right? Um, so you can see that it is it's a same unified interface. This same unified interface. Even though some of them may have vendor specific stuff, right? So um you also get a response. It should be response.text dot content. Yeah, just like the others. Response.content. For with LangChain, it's always response.content. So the reason why this is taking time is this is a big model, so it's a bit slow. And this is what we are saying. Like for a small prompt like this, probably not a good idea to send it to a big model. And also it's probably generating a lot. I'm not streaming. If I were streaming, you would have seen the output coming in. So you can now see that it's easy for you to switch providers, right? I can do this model chat OpenAI, and then later on I can switch to something else, right? And just switch to this. So this is how easy it is. But the interesting thing is that it is actually easier. It's the same invocation pattern, but it's actually easier to now LangChain has introduced a new interface which is called init chat model, right? Yeah, so I got the response here, right? LangChain now has init chat model where you can actually put in the model name, and it is able to figure out automatically how where to get that model, right? Whether which of the API providers it is. Okay. So this is what LangChain now recommends for everyone to use. If you even go to their their models documentation, that's what they will tell you. Init chat model, use init chat model. Um, on the Python, same thing. So the benefit of using init chat model is you can easily do it will easily do the model, but of course you have to put the API keys. It will do the model routing for you already at this point, right? Just init chat model. You have to import this from LangChain um, core, the chat models, import init chat model, and that's it. You now have a model with GPT-5 4. So it actually knows how to route this. You can now set model.invoke, okay, and you specify um, what is a what is artificial intelligence. So of course, it's the API key that is the issue because I did not put that. But I could try a model. I don't know if I put a Nemotron, it might not know. But if I put a Google if I put Google Gemini 2.5, Gemini 2.5 Flash. So you can see I did not specify the provider. Okay, now it says I need to get Chat Vertex AI, which is how it will be able to identify Gemini 2.5. So it's not the Google generative. So that's the newer one. I can install that. Um, it says I have to install LangChain Google Text AI. That is the one that will give us this direct access. The old one, Google Generative AI, is kind of old, right? So after installing this, it will now be possible for it to pull um yeah, let me just wait for it to finish. Okay, so I'm not going to restart the session because it will slow me down. But yeah, some things were already installed and it's trying to install it. Okay, um so you see this, it's able to pull this directly. So this is a lot is going on under the hood. Okay, LangChain are able to map the model names to the provider that will provide it. Um, project ID. Okay, so there's a whole bunch of other things here. Maybe because I use Gemini 2.5 Flash. Let's try the Nemotron. Um, let's try a smaller Nemotron because this one was really big and slow. But I don't think this is integrated into its model routing. So it doesn't know. It doesn't know that NVIDIA Nemotron is is from OpenRouter. So in this situation, because it doesn't know that it is from OpenRouter, what you now do is you can then specify model equals, you can then specify the provider, right? So initial model allows you to say provider equals OpenRouter, and it will now be able to figure it out. So that's just the second thing that you need to do. Okay. It's able to figure it out because I've now told it that, um, oh, sorry, I used the wrong thing. This should be model provider. So you specify the model provider here. And yeah, so you can see that it is able to create it. So this is the highest you need to do. After you specify the model, if it cannot automatically route, it's not in its registry, then you can tell it which provider. And these are the two things. Then you can add the other things like temperature and so on. Okay. So now I can run this. Let's see. So I don't have credits to do this. Perhaps the API key, I feel the API key may have been expired. I think I may have invalidated that API key. Let me try another model just to be sure. So if it still gives me the same error, then I'll say the API key. Okay, so it's not the same error. So it means that this other model I don't have access to. But let's see what the result. It's actually doing something. If not, I would have gotten an error by now. So that's how easy it is for you to use any chat model. So I'll recommend this to anyone, right? Um, but you can still go into the other approach that used to be like the way of doing things, where you would have to do this and then begin to figure out, put them in different if statements, if this and that, if this then that. But now LangChain really makes it much easier. Yeah, so this model is really big, so it's taking a lot of time. It's 120 billion, this 120 billion parameter, it's 120 billion parameter model. That's huge and it's free. So that's interesting. It's crazy. I guess it won't be free for long anyway. So yeah, so this is the response from it. So if you, this is how easy it is. The beauty of this now is that it makes it easy for you to do model routing by simply just um, let the user pick from a drop down which provider they want to use, and then you use this and you pass the provider in as a from maybe a drop down, you pass it in. And of course, when they pick the provider, then they'll pick models that are available with that provider. So you could even do that with Hugging Face or any other thing that you want to use. So the other thing you can do with messages is I want to introduce this a little bit. We'll talk about it a bit more when we're talking about messages. So there's what we call a system message, a human message, and an AI message. Typically, when you are sending messages or prompts to the large language model, you typically want to ensure, first of all, let me go and redo this with a smaller model because this is a really big model and it's going to be slow. So I don't want it to, um, let's see, uh, let's see if this one will work. Nano 9B. Okay. So this should be faster. This is just a 9 billion parameter model. Well, I'm saying just. But it's a 9 billion parameter model, so it's much smaller. This one is a mixture of experts model. Um, so it's big, but it doesn't use all its parameters. That's yeah, what that means effectively. So, a system message is kind of a high level constant message that the LLM will be using, right? So you typically use a system message to give the LLM a standing order. Think of the system message like a standing order. Always, for every prompt that is given to you, always go back to reference the system message. Okay. While the human message is the prompt that you're actually sending. Now, the way this used to be done, and there are so many different ways. If you're using the OpenAI standard, right, you would have done something like this: messages equals or content, right? You have a list, and then you will have this list is made up of dictionary that says something like role is user, right? And then content is you know, you are a cloud architect. Well, actually, because this is a system message, the role would not be user. The role would be system. Even though some do not, I don't think OpenAI had room for that. So the reason for this, rather than just sending a straightforward prompt, is to give additional um, nuance to the LLM so that it kind of knows, okay, this is an overarching message. So this is how it used to be done. You still see some applications where it is done this way. So what has happened is that LangChain has encapsulated these dictionaries into first-class objects that comes with validation. The main benefit of this is type hinting and validation. You will not have type hinting and validation with um, dictionary. So I can't hover over the dictionary, for example. I hover over this and you can see I have what I should type in. That is very helpful to a developer. When you are building, you don't need to try to look for the documentation. You have this autocomplete thing and all of that. And Code Insight, code completion, and this kind of pop-up help, right? Human message, the same thing. So it's a standard interface. So this is how you would send the message. Now, if you do this, right? By the way, LangChain also responds to this format. So it's also still amenable to this dictionary format as well. But in most cases, you want to use their own built-in system message, human message, because this allows, it gives those benefits. It allows for validation and all of that. So this is typically how you manage. Now, if you go and check the response, this is response or content, but after this, I am also going to print the response. You see that the response also has what we call, it also has the assistant or AI message, which is the response that comes back from the AI, also is a structured data. Okay. So, yeah, well, this is because our model is a bit slow. I don't know why. Maybe it's just open router latency. So that's speaking of latency. We probably should be streaming. But you can see that it generated a lot. So I guess that can explain why it took longer. We'll try streaming shortly so you see how much better streaming is. Now, um, so here, if you print response, you see that response is actually a data structure. It has content in it, but it also has other things, right? It has a whole history as well, the message history. This is probably too long. But you see, it has a reasoning thing. Output token details, reasoning 682 tokens. That's the size of tokens that from that's the size of output, right? The number of tokens in the output. Then input token total tokens is 1433. So if the output token is 682, the reasoning token is 682, then the actual output tokens will be 1433 minus 682. And then you see other things. Um, there are no invalid two calls, there are no two calls, and so on. So LangChain structures the data. So you can get a lot of stuff, even get the model provider and so on. Yeah, there's a way to make this response. If we just do JSON dot dumps response and um, indent is 2. I need to import JSON. Yeah, so AI message, this is what I'm looking for. So there's actually an AI message, which is a response. Um, that's the whole response. You would have to make it into a dictionary. So either as dict or dict. So it will be printed up. So this is the content of all of that. Right. So we already did a bit of streaming and you can still do that. So with streaming, you basically call model.stream, and this has even been kind of squeezed into one single API call, right? But you could assign the model.stream into a variable. That variable, we did that already. That variable is a generator, which you can then loop through it. So this also works as well. And you're actually going to see that it's going to print the content um, after a bit of time. It's going to begin to stream it. So you can see it's streaming and it's much better, right? Even though this is a bit jumpy. So there are ways you can make this streaming, you know, more user friendly, smoother, and so on. Yeah. So this is, you can see it's the same thing. It's easy to stream. Most of the SDKs allow you to stream just by calling stream. The other ones we have to call a stream function. generate content stream or something stream. But with LangChain, you just call stream and it gives you stream content. Then you have what we call structured output. So the beauty of LangChain is that we can then force LangChain to you can force the AI to give us a structure, right? If it does not follow this structure, it's going to fail. And it is highly likely that this will fail because the prompt that we have here did not tell the LLM to follow a structure. Well, it did. I guess it did. So, um, oh yeah. So what actually is happening is, LangChain is taking this. This has to be a pedantic model, right? So it has to follow. It has to be a subclass of a pedantic model. So being a subclass of a pedantic model, right? You then use that. Essentially, what you are telling LangChain to tell the LLM is this is the data, this is the output that you are sending should follow the structure. If we were to look at the prompt that ultimately goes to the model, it is not just the prompt that you sent here, but this prompt is augmented with additional information to tell the model that, hey, yes, this is the prompt I sent to you, but your response should be in this format. And LangChain knows about this format from inspection. So it inspects and it knows it has title and duration. So you see how much easier it is. You don't need to even constrain the LLM. This is very important because in today's world, we now have systems that are integrating reasoning models, large language models, with systems that you have already built that are rule-based legacy systems that expect a particular input format. So you use structured model dot with structured output. And it is that model that you would then use to call and you get that. So the benefit of using this is ideally you could have done this structured model. Let me show you how you could do this manually, right? You could do the same thing. I already have a pedantic model. Now, what you would do is something like this. I'll take a model. This one is not a structured model. And I'll do invoke, right? And then normal, let me just call this normal response. Then you would now have um, you would have input, right? Okay, so let's just say you can make it messages. So yeah, input can be just like we did with the other one where we added system message. So I'm just going to bring that up so that we can see where we pass the messages. We set it up as a list, okay, of system and human message. Okay. Now, you could either put that as part of the prompt or you can put it as a system prompt. Whichever way, you would have to do something like this. Then you would have to go tell the in addition to this prompt, you will have to now add another prompt. I will say um maybe /n/n. Okay. Um, ensure that your response is in JSON format, right? Uh, following following this example, this structure, right? Then you will give it a structure. So the structure would be a JSON structure, which would be now I have to do escape, right? Title, title, then title of course, then duration. So again, I have to do escaping because I'm using double quotes inside double quotes, right? Duration, duration. of um, course as an integer, right? So this is the extra thing I have to put into this prompt because let's step back and I just want to show you the benefit of a structured. If I run this normal, remember this is just a normal, I'll remove this second part of the prompt and I just tell it, so I'll print response. Okay. So it's going to do a whole lot of stuff. And oh, I'm sorry, this I should be printing a normal response, not response. So let's do that again. Again, because I did not constrain my model, the model is busy chugging away, creating stuff. It's generating a long sequence here, right? And that's what happens when you don't constrain it. Now, this other one that is coming up here, I now add. Well, it somehow is able to do this. No, it wasn't able to do it. I printed the wrong thing here, so ignore this. I printed the first response, which is correct. But now, here, because I did not constrain it, right? This is the actual normal response. I did not constrain it, so look at what it is doing. It goes on to write a whole bunch of stuff, right? It goes on to write a whole bunch of stuff. And if I were to even take this and normal response dot content, okay, um, okay, let me JSON. Yeah, so the content is empty, but we have a whole bunch of other stuff. So let me again JSON dump it with indent of 2 so that we see the full thing. So it has not given me content, as you can see. Then it gives me reasoning text, Python programming mastery duration. That's the reasoning text. Then the response metadata is this. Then so the AI just did reasoning, but it did not give me any response, no two calls, nothing. Okay. Um, even though it has actually generated it as reasoning text, and I don't know why. Um, so I'll have to go and figure it out and pick it from reasoning text. Maybe because this particular model has been trained, content will not come as, or the API content will not come, structured text doesn't come in content, it comes in reasoning details. So, and I would never have known that. That is where LangChain, comes in. Now, I could also do this, and this time around, I am, let me put this. So this time around, I am giving it clear instruction of what to do. This can either be part of the original prompt, like I have done, or you could put it as a system prompt. So let me run this. While it is running, I will um, JSON dumps. Um, this should actually be model dump. The dict is kind of old. Um, indent was 2. Right. So now because I gave it clear instructions of how to format it, it actually does format it as JSON encoded, as you can see, and it returns that to me as content. Unlike the other one where that response actually got stuck in the reasoning details, but here it's able to send it back as content. And then I can do JSON loads, right? I can now, you know, response equals. So this or course, right? I can then load the course and you now see it. So this is us doing it manually. But with LangChain using structured, it becomes much easier. Model equals, you now do model that with structured output. You specify the structured output, and then you do the call, invoke. I don't need to pass in any system prompt or any additional tweaks to the create a course. So what's really happening in the background is that create a Python course. Right. So this will not work because you cannot pass. I think you have to make it a pedantic model. So we already have course there. So we just use it. And you get that response. So that's the beauty and benefit of using structured text model with structured output. Advantages, so you can see we have that. And not only did it do that, also kind of formatted it back into the to meet the pedantic model. So LangChain has essentially created a connection from reasoning model that is free form, free text to structured data. So you get back structured data without any extra work, and you use that structured data for whatever you want to do. Then we have tool calling. We're not going to talk about tool calling now, right? There's a whole section, then multimodal routing as well. We're not going to talk about that. So I think we've come to the end of our time. Unfortunately, I don't have enough time to do some of these things in JavaScript. But what I can tell you is that every single thing I have done, if you go to the LangChain, you go to the TypeScript, you actually see everything. So let them. You still see that it is the same. Init chat model is the same thing, except that it's now camel case, lower camel case, right? Same thing, rather than using sentence case, which is what you get in Python. You still do model.invoke. The only difference is async. So you're going to await. I get your response. Same thing. Okay. And you can do you know, routing. You can pass in provider as the additional, parameters here. If you go check the init chat model API documents, you get more details on it. You have model and you have additional fields, okay, that you can pass in. And that's how this works. You can do a whole lot with this. So you can see how it is easy just specifying the name of the model. Then invoke is how you invoke the message. It just takes the message as input and outputs the messages that come back from a generated response, completely generated. Stream does the same thing as streaming. Effectively the same thing. You'll be able to get a generator, a reference to a generator, which you can then loop over it and you'll be printing out the output, sequentially. So now the other interesting thing is you have this additional parameters you can pass in. So temperature, we've already seen it. Temperature brings a bit of variability in what your model is generating. Timeout is if the network is slow or delaying, you can time out after a certain time. This timeout is in seconds. So what it means is that if after 30 seconds, the LLM doesn't respond or there's a network issue, it stops so that you don't just keep waiting. Max tokens, we already talked about max tokens. Then max retry. So max retry is that retry thing. It has it built in. So once you specify max retries, what it means is that if it fails to connect the first time, it tries again, the second time, the third time, until after 6 times, then it stops. That's what max retries. So once you specify max retries, that means it will keep trying to make that API request, right? But if you do max retries too much, you could get into a situation where the LLM provider, the API provider or AI API provider will rate limit you and cut you off. So you have what we call back off, exponential back off. So exponential back off is a process where the second time you retry, you wait a bit longer, right? And if that still fails, the third time you retry, you wait even a bit longer. And the amount of wait time between each retries increases exponentially. That's why it's called exponential back off. So that you don't end up hammering the server. Otherwise, you start getting 429 responses. And you know, you'll be asking yourself, okay, why couldn't I do this? Right. In fact, that happened to me yesterday. And even today, I was I was actually doing bulk grading with the agent I wrote yesterday. And after I did half of it, I got rate limited because I did not include max retries when I was creating the agent that I use for it. So these are real issues. Okay. So I wanted to talk about invocation. So it's the same thing, model, await model.invoke. You pass this in, you log the response. You can also do this. So this is what I was telling you before, and you can see on the Python side, you have it as um, models, right? But on the JavaScript side, you use role system content. So this is now the system message. The role is system. So that's the system message. Then the user prompt, the role will be user, right? And content. Then if you have a previous conversation from the AI, it will be captured under role of assistant. And then, so this is effectively a conversational history that has been going on. Is that the first prompt you sent is going to, the system prompt doesn't come from you. Most of the time, it's part of the code that the developer writes. Okay, you as the user, but you as a developer, you are the one that will build the system prompt, right? When you build that system prompt, then the first API call that you make, or the first call to invoke that you make, will contain just these two. And then the AI will respond. When the AI responds, its own response, you append it, and its own response is separate, but you still need to append it to this. So you now have a third one, and then you can then add your own and then send it. So effectively, this conversation object is a list that you are using to track the conversation. This is already what we call memory. We are already kind of implementing a kind of conversational memory here, right? When you do this. So we'll talk about that a bit more and how you maintain that. So that's one way, of course. So this is the built-in classes. You can still decide to use these built-in classes, system message, human message. So the user, the one that role is user is human message. The one that the role is assistant is AI message. The one that the role is user, okay, it's the same thing. So this is LangChain's own interface, right? While this is a standard, this standard was put out by OpenAI and everyone has adopted it, almost everyone. I think Gemini has a slightly different approach. But even at that, it is still compatible. You can still understand this, right? Yes. So the first prompt is, well, I wouldn't say it's a wake up. The first prompt is just the first prompt, right? The system prompt is always there, but the first prompt is what starts the conversation. There's nothing before the first prompt. And I'm going to show you something just now. I'm going to go back to before we close, but I wanted to show something. So streaming is the same thing, right? You can also again you use a stream function to get a reference to the generator. Of course, everything is await, everything is asynchronous. You can now loop over that reference and you get this and you run it. So this allows you to stream, basic streaming. This one allows you to add a bunch of other things. We won't go into this yet. Um, then you can construct, right? So unlike the invoke, which contains a single AI message after the model has finished, the stream returns multiple AI message chunk objects. That's the ND-JSON. Basically, it's taking the message, it's chunking it, but it is still a valid JSON message that contains only a part of the message of the response. So with that, you can then just combine them together. Each chunk in a stream is designed to be gathered into a full message via summation. Then there's batching. There's tool calling. I'm not going to go into tool calling. We have a whole different. What I wanted to showcase here was, I think I've forgotten what I wanted, but I've shown this already. So basically, almost everything I did here, you can do it in JavaScript. Yeah, the structured output is what I wanted to show in JavaScript. So in JavaScript, structured output, you can see it right here. The structured output is you use Zod in TypeScript, but you can also use a JSON schema the JSON schema where you have to actually build this big, you know, um, object of objects, a structure that will define the kind of the shape of the data that you want the LLM to return. So you can use a JSON schema or you can use a standard schema, right? Which comes from this Valley bot, right? Or you can use Zod. So they give the opportunity. I think most people are using Zod these days. So you make a schema with Zod, and the same thing. You just model with structured output. You pass in the schema of the response, how you want it to look like, and then that model with structure that you have created from it, you will now invoke, and you get a response that matches the Zod schema that you had created. So go check out this, right? And you would see. Now, what is the thing I wanted to show before we go? I wanted to show you what happens. Yes, I wanted to show you an example of memory, right? Or lack of memory. So let's try this. You take a model, right? This one is a model with schema, model with schema. Before we go into tool calling, I just create a conversation with a model. So response, let's have a messages, which is a list that contains all our conversations so far. But I'm not using it for now. I won't do anything with that. I now invoke the model. I now tell it my name, right? My name is, okay. That's the first um, call. The response from it, um, oh, it's crazy still doing this because the model I'm using now is the one that I had converted into a model with structured output. So it's still doing that. Okay. Let's create a new model. So model equals init chat model. Yeah, so we'll just go with this. And then I will now say model invoke. Okay, so the response is going to contain um, his own response to that. So yeah, all of this nice stuff and everything. Okay, so take note that it has actually responded and said, "Hello, Aniebe, it's lovely to meet you." Blah 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 blah. Uh, I don't know how it knows I'm from Nigeria, but I saw Nigeria, Ibibio Efik, blah. Aniebe meaning God has done. This is hallucination. It's crazy, man. Okay. Oh well. Um, that's crazy. That's serious hallucination. Okay, we need to work on that. So, but I now ask, the next one is um I now I now um I now ask it, what is my name? So this time let me print the whole thing out. Response. So I can print response dot content, which is actually what it is. So I just told it what my name is. Okay. And then I am now asking it to tell me, to give me back the name. It has no memory of it, right? I just told it my name, and it even went to it went far to telling me I am Efik Ibibio. I guess that one was a nice guess. It's able to know it's Ibibio Efik, but it now hallucinated the meaning of the name. Should I mention that only if it feels relevant? I don't want to assume or overstep, blah, blah. And Nibe can be unisex. Well, it's correct also. No need to overcomplicate, blah, blah, blah. So these things, they like talking too much. But immediately after that, I now ask, what is my name? And it doesn't know what my name is. I don't have access to personal information about you, including your name, unless you're sharing with me in this specific conversation. I'm designed to respect. So, yeah, that is what happens when there is no memory. So, how do you solve it? If you are doing it this way, right? Without using LangChain's built-in memory capability, you have to manage that memory problem yourself. So I've already created memory, but let me just do it. So memory in this case now is just a list. So in the first invocation, response equals model. This is now me using the memory, this thing. What is my name? Okay. Before I invoke, I have to push my own prompt into it. So we can now do something like prompt. This is where we now start it. Prompt equals what is my name? Okay. Sorry, my name is Aniebe. That was the first prompt. Good. Then I append it. So you can say append it. It's just a string though. I could have appended it as user. Let's do it properly. Typically, the right way would be to say a role is user, or just make it a human message. That's another way you could do it, right? We could just say human message, right? Um, and then you can append that. Okay. So you invoke the response. The response is going to be an AI message, right? When that response comes, we will still append it to the memory, right? Response dot um, um, content. Okay. So we have added into we can even print the memory, right? One way to do this, it's a bit challenging now because we now have a list of stuff, but it allows you to see this. My name is Anibit, right? Um, so Sorry, I did the wrong thing. I'm supposed to now pass the memory, okay, in. I can pass the prompt alone, which will still work because that's the first prompt, but subsequently you want to be passing in the memory because the memory contains, okay, yeah, this is not working because um, it must be a prompt value. So a prompt value, the human message doesn't work. So we have to pass in the memory. The list of conversation is acceptable. That's considered a prompt value. But a single human message is not considered a prompt value. So I'm now passing in the memory that has the conversation. I get the response from it, which it now responds to me. Um, so the content, this is my own first part of it, right? Um, this is the first part, which is me. Then this is the response that comes from the AI, right? Um, the only thing is I did not do this properly. I should have appended the response, not the content, because when I append only the content, I am throwing away the metadata. That metadata is very important. Particularly, we need to know that it is an AI message that is in there. So I start off with a prompt. I push the prompt into the memory. So this memory is now the holder of the conversation between me and the large language model. So I first push my first prompt, and then it is always the memory that you pass into it. This memory contains the entire history of the conversation. That makes it very convenient. So I now get a response. When I get this response, I push the response. The response is an AI message. So I created a human message and I sent it. I get an AI message back. I push it in. It has a bunch of metadata as well, which I am not going to go into. Then in the next conversation, I will now, first of all, memory will now add another human message to the memory, right? Which is the next question. What is my name? Now it will know how to answer my name. In fact, let's have another conversation in between. What kind of model are you, right? I append that into the memory and then I still use the same thing, right? Response, memory.invoke, okay. And um, it now has a full memory of the previous conversation, what I asked it, what it responded, and now it is now giving me the content. I am Nemotron. But note that I have to still push this memory into, sorry, this response into the memory. So I do that the next time. Um, again, memory. For those of you who are sharp and who are developers, you are already going to start feeling like, why do I keep repeating? I'm essentially repeating the same code over and over. Why can't we put in a loop? Exactly. We can put in a loop or even in a function call. So this response now is the next AI response. Then I will now append the next question I want to ask it. This time around, I'm going to ask now, what is your name or what is my name? Okay. And this time it should know the answer because the first question I asked it is in the conversational memory. So your name is Aniebit. You shared that with me at the very start of our conversation. So you can see that what makes it have memory is not inherent in the LLM, but it is the fact that we are keeping the history of the conversation. And when you send the whole memory, like what we are doing now, as the prompt value, you are sending the entire history. So the LLM is actually going to read everything from the first conversation all the way to the current one. Remember, large language models are predictors of the next character or the next token. So that is what will allow it. So that is why you now see the matter of context window becomes very important, because context window, as the longer the conversation, the longer the history. Whether you're using VS Code, Copilot, whether you're using ChatGPT, Claude, all of these things, for them to have that memory, they are keeping the entire conversation history and they're feeding it back into the LLM API call. So that's where you now hear of context window needs to be large enough to hold that history. Later on, we're going to talk about how to manage memory. If it fills up the context window, what do you do? There are different ways you can trim the existing conversation, the history, so that you don't run out of context window. So this is just the last thing I wanted to demo on this. So you can see how powerful LangChain is. You can even see LangChain already made it easy for us to manage the conversational history. Go and try doing that with maybe any of these provider SDKs. You need to do a bit more work, even though I think everyone is generally kind of adjusting to this same pattern, because we now know that memory is key in a conversational interface. That brings us to the end of our class and our study on SDKs, APIs, and of course the LangChain SDK for model, for handling models. So next week we are going to, so let me just give you a preview of next week. Next week we are going to now go into multimodal large language models. So that's large language models that we can do image, we can do text, speech, we can do all kinds of things. So hope to see you then.